So suppose I have a pen, like a Bic pen, so a plastic rod that's hanging down by a thread, and I rub it with wool, and then I take this Bic pen and I rub it with wool, and I bring the two together. I notice that this hanging Bic pen moves away, so it feels some sort of repulsive force from this pen. So just investigating, we know there's got to be some sort of interaction, and it's repulsive. Now if I replace this pen with a glass rod that has been rubbed with silk, so I'm going to just make it now maybe filled in to represent it. We've changed it, it's now a glass rod, so we don't have this anymore. And I rub this with silk. This is still rubbed with wool, okay? And now I bring it close, it will then be attracted to it. It'll swing towards the glass rod. And so you see that there's different types of effects. If I rub plastic with wool, and it must acquire something that has a positive effect near another plastic rod that's been rubbed with wool, meaning positive means repulsive, it's pushed away. And the opposite is true if I rub a glass wool. So we can kind of establish there's like two different types of interactions happening depending on how you prepare either a plastic rod with wool or a glass rod with silk. And so we start to establish the existence of something. We can call it charge. We can say it acquires a charge. We don't really know what that means, but we just say that. Okay, then we can do some other stuff. So for example, we can see that if we bring the two of the same together, they repel. So we can say that like charges repel. So that's something we can conclude here. Like charges repel. All right, and opposite charges attract. Okay, so there's some rules that we start to build up. Now, as we go into a discussion, there's all sorts of different experiments we can do to refine this model and understand these charges, these things we call charges, better and better, and then start to discover how they work in great detail. So with this is just kind of a beginning. We can also look at size and distance. So if I rub the plastic a lot and rub this glass a lot, okay, with wool here for the plastic and silk here for the glass, then that attraction is much stronger. And so the size of this repelling force or this attracting force grows with the amount of charge I put on it. Another thing we can do is we can take this glass rod, so we'll take this case of a plastic pen and a glass rod, each appropriately charged. And if the glass rod is far away, then this force is really small. It doesn't swing very much. But as I get closer, it starts to swing a lot and dramatically so. So if I get this really close, this is really swinging high. So I can see that the size of that force grows significantly when the distance gets smaller, so it has an inverse relationship there. So with those, we have this inverse relationship, means that the force is proportional. That's what that symbol means. It's kind of like an open-tailed fish. Okay, the force is proportional to the inverse of the distance. So I'll do 1 over r. Okay, somehow. Now we don't know exactly how. It could be r squared, r, we don't know, but just as the distance between the objects gets bigger, we know this force gets smaller. So again, we can establish that with just these simple experiments. So somehow it's proportional to the inverse of r, and it's also proportional to the size of the charge. So it's proportional to the charge size. Okay, with these two rules based on if it's the same type of charge or opposite charge.